Fair, you're muted.
I don't know how that happened, but there we are. Oh, okay. So we got everybody here. Well, almost everybody. Almost half, actually. But I think we can go ahead and start. We're in our last weeks of the class here. All right. And so we need to start thinking both about the assignment and about the final exam. I will have some final exam review materials up and ready for Monday. All right. But actually, one of the funny things about our class is, let's take a look at the topics by week for a moment here. Already got it up. There we are. It's on Moodle. There we go. On Moodle in topics by week just now, the lecture notes. Okay. There'll be a new tab for exam resources on Monday here. All right. But today we're still going to focus on the assignment. All right. What we need to do is, we didn't quite follow this exactly, all right, but we're right on track. This is the week of the 22nd of November, all right, and we're going to swap these two around and talk about shared folders and the Monkey virtual servers enhancement today, and in the lab on Monday. All right, we'll leave log files and regular expressions for next week. All right, and then by this week, 6th December, we will have this week, 6th December, we'll be covering our last topic on user management and accounts and things like that. Last week, we'll consolidate, focus on exam review. All right. I'll set an exact due date for the assignment. We'll have an exact due date next week. All right. But due to the calendar, all right, we've got actually a 3-week break. It's 3 weeks, isn't it? Week of the 26th of December is buffer week. And then, actually, that's a holiday week, all right, because 24th of December is a holiday, and the APU is closed for these 2 weeks. And then exams start this week. So there's quite a distance this time, all right, between the end of our class, all right, somewhere here around the 17th of December. We're missing a week in there somehow. Oh, that should say 20. That's what happened. That should say 20 December and not 26. So this is buffer week, all right? This week and this week, the campus is closed, all right? And then exams start here on the 10th of January. So we'll take that into account, right, with our exam resources and our exam review. Right? But just so we know how things work, just so we know what to expect, I'll have to fix that somehow to say the buffer week is the 20th of December. But that is the timetable. So the point is, we've just got a few more topics to cover, and we're in very good shape to do that. All right. One of the things that we want to do today, we had a little, we had a lot of technical difficulties for this session last week. So we're going to start there today and pick up with some points that we did not have time to cover. All right, we focused mostly on the practical part for that. And we need to get back for a little bit more theory. All right. So that's what we'll do first this morning. All right. And then after that, we'll talk about NFS, Network File System, and shared folders. All right. Sharing folders. We can share folders across operating systems, as long as we've got the network up and running. And that becomes a very nice thing, right? Because it allows us to use permissions to segregate access, but still have it available in multiple places, right? And that goes to one of the enhancements on the assignment, all right? And so we'll start on that topic after we finish up talking about firewalls, and especially about the network configuration and some of the classes of firewall software, including what they call intrusion detection systems and intrusion detection and prevention systems. Okay, so that we've got those concepts in our mind, because that's the sort of thing that is the theory, that is what final exams are made of. All right, so let's turn off the camera here. And let's start by reviewing our topics that we didn't have a chance to see last week when we were talking about firewalls and packet filtering. We went on and talked about the practical aspects of this, okay, last week, which is fine. Right? But again, there's a couple of theoretical things that we need to be aware of on this topic, right? Because the network architecture and thinking about security when we design our network is, again, a responsibility that goes beyond just the security specialists. Everybody involved with system network administration has this certain degree of responsibility for thinking about security. Strict control over access to system configuration files, controlling our privileges, all right? We've actually worked with that a lot, okay, when we're setting permissions on our system startup file, okay? Encrypted communication channels using SSH, all right? Using S-tunnel to secure the communications between our servers. For our practical example, between our servers, but SSH everywhere is becoming a huge, huge trend in the world at large, right? Tracking and reporting attacks and vulnerabilities, that's more something for the security specialists, right? But having some knowledge in that area is always good for everyone. And then this idea of a single point of failure, right? A bottleneck, something that if it goes down, right, it disrupts regular use of the network by the people who need it to do their jobs. And for us as systems and network administrators, that is mission failure. And believe it or not, I got an email a couple of days after our class where I was cut off for as long as I was online, saying that the cause of that problem was the firewall and the intrusion prevention system. Something was not working with the configuration, okay? And that's what had an impact on us doing our job, reaching our goals, right? And that means, you know, I suppose that illustrates two things. One, it's complicated. There are a lot of complex systems here and a lot of moving parts that need to work together properly, right? And the other thing is, when these things happen, it's important to communicate with the users about where we are in trying to get this problem addressed. All right, so we talked about this idea of a firewall being that actually single point of failure. What we're trying to do is isolate traffic in our network, right, from the people, the people on the inside. And so we think about having a space that is behind the firewall, protected, right, and the unprotected space where all of the action is and anything can happen. All right. So that examines all of the traffic that is entering or leaving the internal network. All right. We saw that with IP tables. We've got rules for incoming traffic that we're experimenting with, the input rules that we're experimenting with in the enhancement for the assignment. But there are also rules to allow or deny traffic going out of our network. And another kind of rules called forwarding rules that only make sense on the gateway, right? Because forwarding means if it comes in on the net A interface and we want to contact the mail server on the net C interface, we can look at the source of that traffic, where it came from, what protocols it is, right? The basic features of that packet, and decide if we're going to let it travel from net A to net C. Those are the forwarding rules, and again, they only make sense on the gateway. All right, so this is where we're working, network layer firewalls, packet filters, all right? This term, stateful, means that we can monitor the three-way handshake. We talked about that earlier, all right? The sequence of empty packets with certain combinations of flags set that we use to establish this TCP connection. Right? There are some special rules. There's some specific examples All right. It's not the specifics that are important for us, though. It's just this concept that for a TCP connection, we can check and see if it's established or if this is just trying to establish a connection. Right? Empty SYN packets coming in, right? Because there are some people who like to attack our network using that technique. Now, this host-based firewalls, this is a really 1990s distinction, but everybody believes it's important and everybody talks about it this way, so we will as well. The basic distinction between a network layer firewall and a host-based firewall is a host-based firewall does not have forwarding rules. All right. And I don't know. Actually, I think even Windows firewall has forwarding rules. All right. And so this distinction is pretty irrelevant now. Right? But people still talk about it. So we still want to be aware of it. Proxy is sometimes what people refer to this as an application layer firewall, all right? But they look at traffic specifically for a particular service, all right? And pass it along. Sometimes they'll rewrite the packet before it goes out. But the place where we usually see this, all right, is in our really the place we see this the most here is in our browser settings. There it is. Open your computer's proxy settings. Right. And again, this goes to the network architecture, proxy server. Don't apply to VPN connections. A VPN is a different thing, as we talked about earlier when we were talking about SSL. All right, but what this does is it kind of redirects certain services, okay, to particular services, all right, an address and a port, all right, and we can set that up. Usually, we see this, it's set up per application, but this one is working it in Windows itself, which is a Windows 10 feature that I think I was a little bit unaware of. Application layer gateways, layer 7 firewalls, next generation firewalls, all right? These are different because our IP tables firewall just looks at the packet header. It does nothing with the data, right? And these are layer 7 looking at the data part of the packet to look for suspicious patterns in the payload of this packet, all right? So an example of a suspicious pattern would be something like cross-site scripting, where we're passing bad instructions to a web server CGI program, all right? And so looking inside there. Now, obviously, this means that there are going to be lots and lots of things to look for, because different protocols will have different types of attacks that can get embedded in the data section of the packet, right? And as time has gone on, all right, people have really stopped talking too much about layer 7 firewalls and talked a little bit more about intrusion detection and intrusion prevention systems. So at this level, where we're talking about examining the data part of the packet, the terminology starts to explode, because every vendor wants to have a new name for their product to make sure that everybody recognizes that it's different from all of the competing products in the market. So don't take it personally, all right? All of this confusion about terminology is just because people are trying to push their products. All right, now we talked about access control lists, the idea of a default security policy that basically determines the kind of work that the systems and network administrators have to do, right? Each policy creates a different kind of work, and that's our only choice, all right? There's no escaping it one way or another. We're stuck with the work. It's just the type of work that we want to take on, all right? Having a deep understanding of everything that's going on in the threat space, right? Or having a deep understanding of how our users are using our network and the services that they require in order to get their job done. It's just a choice that we have to make. This part, because this is the part that we have talked about, access control lists and oh, I see. I think my slides could use a little bit of reordering here. All right. This one is one that I wanted. I don't know if we gave this one proper attention, all right? But this is the essential idea of network architecture as well, all right? We have the, remember we just looked at that airplane and that old Volkswagen Beetle with the engine in back, all right? We said the firewall, right, protects the inside network, the network that's behind the firewall, separates it from the internet, the motor part, the outside world where everything can happen, all right? And so what we have to do is decide where we are going to put these firewall rules. Right. Now, sometimes we have what we call a DMZ, demilitarized zone. There used to be a few of these around the world. The only one I can point to anymore is the one between North and South Korea. All right. In the firewall or network architecture use of this term, right, it means that we have some publicly available services, right? So we might have web servers there, might have mail servers there, so that they have pretty much unrestricted access for incoming traffic from the internet. Instead of DNS there, I might put LDAP. But basically, what we do is we have some unprotected servers here. And then we take some extra care. For example, on this web server, we put all of our public information. Okay, but all of our order forms and all of our payment collection information and all of our customer personal data, all of that needs to be on the protected network behind the firewall. So we have really strict rules on this one. Okay, and this can be a gateway. This is the Cisco icon for a router, but our gateway works exactly the same way. We would have really heavy firewall rules here, and not so many here. The alternative, put really strict rules, keep whatever out, whatever comes in from the internet that we know we don't want, keep it out, and don't ever let it in. And again, this goes back to the idea of what kind of work do we want to do, Do we want to keep track of everything that's happening here and potentially miss out on some important traffic because we're trying to keep out as much as possible? Or let most things flow through here, at least this far, where we can capture them and examine them, and really strictly control access after this point. Now, here's another term, and again, IDS and IPS. Again, slicing these hairs just a little bit thin with our modern software architectures, since 2010 or so. The distinction between a firewall and intrusion detection system has been blurred, by the development of the features in the common software, But the intrusion detection system, one of the big differences between an intrusion detection system and the IP tables kind of firewall is that the IP tables firewall only looks at individual packets. The only time it can think about more than the packet that's right in front of its face is with a TCP connection that has been established, already, what we call those stateful firewall rules. There is absolutely no degree of sophistication in looking at sets of packets because we want our packet filtering firewall to be lightning fast, So usually we'll try to separate that. We'll have a firewall running with its firewall rules. Anything that passes through the firewall can get caught and examined by our intrusion detection system. The intrusion detection system does two things. One, application level firewall, looking at the data part of these packets, which our IP tables firewall does not do. Second thing it does is it can look at patterns of traffic. We can set a window of, say, 2 seconds or 10 seconds. Generally, that's about all we're gonna do, because again, we want this to be fast enough, But we want to be able to look at a pattern of packets coming in. Right? The three-way handshake is a perfect illustration of a pattern of packets. But if we start getting deeply into forensics of malware and how it spreads, right? We're looking at McAfee or Kaspersky or something like that, right? We look at the way the malware writers are trying to distribute their software, how they try to install it on our computer. That's forensics, right? But forensics feeds back into security practice. And so when we have an intrusion detection system, we can write a rule that says, if we see a packet, well, if we were writing this for the three-way handshake, we would say, all right, I want to see a packet with empty packet, only SYN set, and I want to see my packet going back with SYN ACK, and then I want to see another ACK packet coming in. And once I see that pattern, I let that pass through because that's the normal TCP handshake. If I see a different pattern, right, then I'm going to want to do something about that. Right? So, thin scan, for example, right? We talked about that one when we talked about the IP tables rule. So I see a packet with only a FIN flag set, right? Coming into port 80, then another one coming into port 81, then another one 82, then another one 83, 84, 85, all right? Or even randomly from the same IP address, right? If I can find a pattern like that over a short period of time, I say, this looks like somebody doing reconnaissance on my system. They're checking all of the ports to try to see if there are services there that they can attack. Call that reconnaissance when we talk about an intrusion lifecycle. Right? So this kind of reconnaissance pattern, right? IP tables can drop one individual malformed packet, can drop each individual malformed packet as it comes in. But other patterns get through to the intrusion prevention system, which looks at the traffic pattern for a short window of time and makes decisions about, is this normal traffic or is this potentially malicious traffic? Right? And there's various ways that this can be done. Right? Network-based intrusion detection is very common. Right? There's a software called Snort that is very well known in the open source community. Okay. There are log file monitoring programs, okay, so that we can, after the fact, look for patterns of malicious behavior. All right. That may not that may not be as good as trying to stop the attacks in real time, but it also doesn't slow down the throughput across the network. So again, we've got this security versus usability trade-off, just like making people have secure passwords and change them every so often. Whether we try to tolerate a little bit slower connection across the network by examining in detail all of the packets coming in, or put that off a little bit and analyze it from the log file. Again, it's a decision that we have to make about the network architecture, which goes directly to our responsibilities as systems and network administrators. File integrity checking. Yeah, a lot of people put this into intrusion detection systems, okay? What we do is we keep a database. We keep a database of hash output, message digest. We run the file itself through a hash algorithm, right? Come up with a message digest, keep that in a trusted stored database. And then every so often, maybe once a week, right? Or once every few days or something, or whenever we think somebody might have gotten into our system, right? We can run the file integrity checker, which, as we would expect, just takes every file on its list, runs it through the same hash algorithm, compares it to the one in the trusted stored database, and sets up an alert, right? If something has changed, so the systems administrator can go back and restore that file to its proper state. Now, here is a key point, all right? Technically, and according to its proper definition, an intrusion detection system only detects malicious traffic. It doesn't actually do anything except signal an alarm, right? That might be a message on the screen. It might be an SMS. It might be an email, right? But basically, all it does is set up an alert. On the other hand, the intrusion prevention system, oh, there it is. Let's skip the false positives and the false negatives. Right? The intrusion prevention system, right, incorporates an inbuilt packet filtering firewall so it can stop that flow of traffic. Right? And again, this has gotten to be kind of a historical, if you like, historical distinction, right? Because our most up-to-date, the sophisticated tools incorporate both of these functions. So technically, we have packet filter firewalls, simple ones like IP tables, and intrusion prevention systems, okay? And that's the state of the security software that we have in the current day. And of course, unified threat management, all right? Trying to centralize all of these things into a single system, right? And again, there are lots of variations on this. I think Cisco coined this term back in the late 90s or just after the turn of the century, okay? And it's still with us. And so we just need to be a little bit familiar with it as a term that describes the current state of evolution in these software tools. Yeah, and there we are. We're in the IP tables rules. Okay, what time we got here? 9:13. All right. Now, there is an example. This is covered on the website, and I just want to cover this quickly, all right, because there are a couple of other classic tools, all right, that we can use. There's only 3 slides here, all right. One of these is called TCP route, Right? Now, this is a little bit like a packet filter built into the application. Right? It's a little bit out of style, but it's one that is available with the TinyNet. Right? Is that when we compile the code for example, Telnet or Dovecot or Postfix or whatever service we're running, right? We can compile it with this special library that directs the application before it opens the connection. It checks two files, etc hosts.allow and etc hosts.deny. Right? So these are the access control lists. And this gives us a lot of flexibility because we can control it on the basis of source address and all kinds of other things like time of day, right? And we can use the other difference, I think, is in the next slide here. All right. One of the other differences that makes this easier than writing IP tables rules is that we can use domain names instead of IP addresses. And that can be important because a domain name can actually have several IP addresses, and there can be several domain names associated with a single IP address. Several domain names associated with a single IP address, that's what our CNAMEs are about, right? DNS masking CNAMEs, we put in a new CNAME, we can have a new name for the server, all right? So using TCP wrap, right, we can control access to specific services, okay, and write access control list rules that are a little bit less cryptic than they are for IP tables. So this is a nice alternative, right? But again, what it comes down to here is what kind of work do we want to do for ourselves? TCP wrap is simpler. Rules take effect immediately. Can use domain names. IP tables is faster. Rules are more difficult to write and require a restart. All right. And the one which one is, oh, we forgot about this one. ExoNetD. All right. ExoNetD is a third alternative. Right? That's the one we used for, oh, remember back in the day when we were doing first things first? And one of the first things we did was say, you can only use the Telnet service from the localhost IP address, from the keyboard. All right? So access control restrictions, ExoNetD also has the ability to control things on, for example, time of day, right? Or there's several other combinations of filters that you can use when you dig into the documentation. So we've got IP tables, TCP wrappers, ExoNetD, all right? Lots of ways to divide things up, but the only important thing to remember is that when we're stacking up these various tools, don't have redundant rules, and even more, don't have contradictory rules, all right? So if IP tables drops it, it's never going to get seen here, all right? Now our effort writing rules has gone for nothing, all right? If there are redundant rules, we're just wasting our time a little bit, right? As we pass it through our various layers of security here in terms of filtering our packets and filtering the traffic that's coming into our network, filtering access to specific services that we're running on our network. Okay, so that, yeah, we talked about that part, and some interesting reading here, all right, about securing particular services, not on the final exam, all right, but interesting reading, especially up here in chapter 2, attackers and vulnerabilities and common exploits and attacks, all right. The Red Hat Linux Security Guide is a little bit older, all right, but all of this is as relevant in these modern times as it was when the authors took the effort to share this with us. Okay, so that catches us up with some of the topics that we got denial of service out of last week. All right. Let's take a little break and then move on and talk about shared folders and such. Let's come back at 9:22. Let's come back at 9. Oop, did I say 9:22? It's no. Let's take more than a 30-second break. Back at 9:32. Okay. Let's see where we're at here. All right. I just decided that I need to get a diagram from a different PowerPoint. So hold on just 1 second while I grab that one. All right, that'll be a good starting point. I'll put in one more here. I'll do that right now. There we go. All right, good. That's my whiteboard slide. Okay. Right. So what we want to talk about now is the enhancement on the assignment for virtual servers, all right, using our Monkey and our DNS, all right. The basic idea here is that we can set up each person that we want to give a website to can have their own domain name, as it were. They can have their own name for their site on the mytiny.net. All right. And this is the common way to do it. There's an old-fashioned way to do it that had a little wiggly thing in it. All right. But people decided that that was not the best way, and it's very unconventional now. It's considered very 90s, right? Because what we do now is we create a site for them using the capabilities of our web servers that are called virtual servers or virtual hosts, okay? And then we can take the name of that virtual host and put it into our DNS as a CNAME, and people can access the server, right? And the server will sort out exactly which virtual server it's going to take the pages from. Now, that sounds a little bit complicated, maybe it is, but it's actually quite simple. It's one of the reasons we use Monkey Web Server, right? Because the configuration file is so simple. So let's switch over here to the project resources document for a minute. All right. VPNs, S-tunnels, we talked about that. We'll talk about this one next week. Should be of special interest to the everybody in computer science. IP tables, TCP flow. Here we are. All right. So this comes in two parts. All right. And again, these ones that have two parts, all right, it's because there is a dependency. All right. So if you want to do this one, you must do 3.1 first, all right, because that's the foundation setup. And this is essentially an enhancement to that enhancement, all right? So it's a two-stage thing. If you do stage one and do not do stage two, fine, no problem, all right? Maybe you only want to do that stage 1 and go on to something that you also find more interesting than stage 2. That's fine, no problem. But if you want to do stage 2, you can't until you get stage 1 finished. It's the same situation up here with LDAP, all right? There's no point in doing a new DIT until you have dovecot and squirrel mail using LDAP for address lookup and for user account lookup. So you can set that up, get dovecot and squirrel mail using LDAP, stop there, go on to something else. Go on to virtual hosts, for example. Right? Or, again, it's up to you. You can enhance the LDAP enhancement by adding another phase. How do you decide on individual or group enhancements? Is all up to you. Okay? All up to you. Here's my smiley guys. I just see how things are designated in the report. Okay? So it's all up to you. It's a group decision. Can collectively decide which one is group and which ones are individual. Okay? All I see is how they designated in the report. It should be clearly labeled if this is an individual enhancement. And these are the group enhancements. I'm not going to micromanage your group and tell you exactly how to do this. All right? You need to. That's what group work is about. Okay? You need to make a group decision, right, about what you want to do. All right? Individual parts are straightforward, but for the group enhancement, the difference is just the contribution will be divided. In fact, yes. Another way to say that is everybody in the group gets the same, shares the mark. Everybody in the group shares the mark for the group enhancements and individual marks for the individual enhancements. Is that okay? All right, good. And I'm just going to emphasize this. If there are any complications, need to be mentioned in the If there any complications, they need to be mentioned in the peer evaluation of group work. Okay? It's a sad fact that group work does not always go as smoothly as we would like it to. All right? Peer evaluation is there. If everything's cool, just say so. It's fine. All right? But if anything is complicated or something goes wrong, get it into the peer evaluation of group work, because I cannot make any accommodations if that is not there. I need to know, and not only me, this is why it has to be submitted, not only me, but the review of results committee, the external examiners, the internal examiners. There's a whole bunch of people. APU has a well-tuned system for making sure that lecturers do not make arbitrary decisions about marks. Right? It's checked and rechecked, and what the checkers did is checked. Right? And so you need to have that peer evaluation of group work to provide a basis for any accommodation. All enhancements have the same points. Big yes on that one. All right. Meaning that no matter which exactly we choose, it will be given a mark as long as it is, it's going to be given a good mark as long as it's fully done on the current system, and the screenshots show the TP number of someone in the group. Okay, that's the criteria. All right, if it's partially done, I'm not going to get a good mark, but it's going to get a mark. All right. If it's missing, obviously, there's no mark for things that aren't there. Okay. So yeah, and that's the idea, and that's why some of these are phase 1 and phase 2, is to keep the size kind of even, all right, so that you can just kind of divide things up, and you've got this flexibility. There's not some that are giant and some that are small. Everything is about the same level of challenge and effort. At least that's what I'm hoping they're designed to be that way. Right? So that's why there's these part 1s and part 2s, to keep them all kind of even. Okay. Everybody good with that? Okay. Obstacles encountered, obstacles overcome, outstanding unresolved issues. All right. That's a catch-all. If it all went smooth, all right. Again, it's just a kind of a catch-all space. All right. If everything went smooth, just say so. I know it's a problem with forms that everybody gets all this idea that if there's a space on the form, it needs to be filled up. All right. But those two spaces in particular, all right, are just there in case, all right, you want to reflect or, you ran into some problem that you didn't know how to solve, okay? Just so I know that you realized it, and it gives you just a chance to explain, right? If there is, again, some outstanding issue, right, or some particular complication that you had to deal with. If it all went smooth, just say so. That's all good. That's the way I'm hoping it is. Right? I'm hoping everybody leaves that one blank. Template is not just helps you YPU to make sure just helps you make sure everything is done. Okay? And you don't have to use a template. You don't have to use the boxes. You can be a little bit more free form if you like. All right? But just to say, it's got just a little bit of details there. You don't need to, this is not a this is not a literary exercise, all right? Complete paragraphs are not required. The real thing, the real substance, let me put that instead of real thing. This is a show me how kind of a, show me how you can do it, all right? So it's not a literary exercise, and don't worry about formal. Save yourself the effort. There's no, okay, yeah, just if you're using the template, I mean, you can delete those pages, which is nice, all right? Or you can delete those pages, or you can leave them there and I'll scroll by them, all right? It's not a big deal. How many tests do you need to do for GCC? For GCC, do enough tests to show that you are having fun. How's that for? How's that for a guideline? All right. If you if you want to I mean, the basic idea is to show that it works, all right? But, you know, it doesn't take a lot to copy a line in your script file and generate a few different things, okay? Sorry. Yeah, like that dancing penguin guy. Have a bit of fun and, you know, flap your arms and dance around a little bit. As I say, it doesn't take a lot of effort to copy a line in the script and, you know, show the date in rainbow colors and a little bit of a message that says, you know, dancing penguin or something like that. Whatever you find, whatever catches your imagination. Okay? Any more things on the assignment while we're here? No? Due date? I'll have an exact due date next week. It's definitely not due on the 13th because that's a Monday of the last week of class. All right? It's going to be after that. But exactly what day? I'll have it on Moodle next week. The assignment link, the submission links will be open. All of that will be ready next week. Okay. All right. So let's go back and talk a little bit about this virtual servers and virtual servers with NFS, this pair of enhancement step 1 and step 2. Okay, and again, if you don't want to do step 2, that's all right. But if you want to do step 2, got to have step 1 done first because it takes that much work to get the groundwork laid. All right. Yeah, that stayed up this time. Okay. Oops. Turn off that camera. All right. So, virtual servers. All right. Just let me come back to my PowerPoint here for a minute to explain our motivation. All right. Right. So when we talked about the web server architecture, all right, we said that web servers are basically very simple beasties, all right, in that what they do is the web server itself only serves HTML pages from its local pages repository, all right? Hang on a minute. Just. Oops. I'm going to clear that one out as well. All right. So it comes in from the web client, all right? If it's a simple request, like give me the home page or whatever, all right? It's just grabbed out of the stock of local pages, all right? Or if it is a complicated thing like we're submitting a form, all right, then it has to be handled by a CGI app, all right, which can access either local files or sometimes we'll hook it up to SQL Server or MariaDB or Postgres, okay, to handle things that might come from a database. And this idea of virtual hosts is that multiple websites can be managed by a single server. All right, which means that in order to do that, we set up multiple document routes, one for each virtual server, all right, and multiple stocks of, multiple directories, one for each virtual server, where the CGI apps are stored. All right, so that's what 3.1 is about. All right, 3.1 is about setting up these virtual hosts. 3.2 wait a minute, where's my shapes? There it is. I'm going to draw a box here. Draw a box like this. Oops, not there. In 3.2, yeah, that's what happened there. Hang on a minute. And let's kick that line up a little bit. Okay. Now, the idea of 3.2 is on a different put all this on a different server and share it with all right. So the idea of 3.2, all right. Well, actually, the idea of 3.1 is that we set up a separate server with this all together, all right? And then in 3.2, we take this and share it with our main web server across the network. Let me try a different diagram here, all right? And show you what I mean. Hang on a minute. All right, so I've got a user server. And I've got a, oops, let's make the web server over here. And a web server. Right? Now the idea is that I've got Arnie and I'll have Arnie and Betty. Right? Arnie and Betty log in to the user server. all right? And put the files that they want on their own particular website on the user server, okay? And then let's use a different arrow here. And then we use something called NFS, the network file system. Hey, come on, don't make me do this. All right, so that the files that Arnie and Betty put on the user server, right, it makes it look like they get transferred, but actually they're just shared, right? They always live here, but across the network, the web server can see those files, right, and serve up the website. Now, the reason we do this, okay, is so that we can have one web server, right, that handles everything, but we can keep it more secure because we only have login. The only people who can log into this are system administrators. This one over here, all right, is the one that is open to the internet and anybody can log into this user server. So this one may get attacked, all right, but it won't interfere with the operations over here. All right. These sites may be at risk, right, but what we keep on the web server will not be at risk. So this idea of file sharing across the network, you can see it any place here. All right. If I look at file and the properties, all right, and security, all right, oops, those are all special permissions. Maybe I have to do this on a folder. Let me try it on the folder here. Ah, there it is, a shared folder, okay? So I can set this up to share this folder across the network, all right? And I can set, as it says here, custom permissions and some advanced sharing options. Now, the thing is, this works across a Microsoft network. There's a way to do this between virtual machines and Windows. All right? There's a way to do this between virtual machines and Windows, but sadly, it's not set up on our TinyNet yet. Here in orientation and shared folders, right? It gives you the full story, all right, about sharing folders between machines. And there's various ways to do that, all right? One way, if you want to move, this is really the easiest way, if you want to move things off your Windows machine and onto a virtual machine, all right, just go to portableapps.com and get WinSCP, all right, because WinSCP works a lot like MC, all right. You just set up the network connection between your Windows and, oops, Windows and your virtual machine, all right? And it works just like MC. This is your local machine. Over here will be the one you're connecting to. And if you right-click, it gives you an, oops, you can't see it now, all right? But if you right-click on a file when it's connected, hit upload and download option. Just like MC, 2 windows, 2 different file systems. This one happens to be on one server. This one happens to be on another server. That's why we don't have the shared folders thing running for Windows, all right? Because this way is too easy. VM to VM, MC, you can do exactly what you just saw, like WinSCP, with F9 and shell link, right? Under left or right, okay? Type in the IP address of the other machine, automatically connect, we give you an SSH connection. You will probably, especially the first time, get an extra message about saving the certificate. All right? Do you trust this host, and shall we save the certificate to make this process a little more automatic next time, which is fine, okay? And again, you can move things back and forth. It says shell link here is a one-way connection. I have to say, sorry, that is out of date documentation, all right? It's actually a proper 2-way connection now. Alex Schmidt, I'll say this again. Okay. Mount a USB drive to the virtual machine. Ouch, man, you can do that if you like. I don't really like to do that. Mount the Windows shared folder under construction still, all right? Mount a Linux shared folder, all right? This is the classic method of sharing directories between Linux hosts, and it's called NFS for Network File System, all right? Windows actually has a different protocol. NFS is actually just a protocol, a client-server protocol, all right, that allows this sharing. Windows uses a different one called the Common Internet File System, CIFS, all right? But the effect is exactly the same. And NFS is the classic way to do this on Linux, all right? So especially all you network computing and cloud computing specialists, all right, should be familiar with NFS, because you will be dealing with virtual machines, all right, as part of your career expertise. All right, so there's a brief review of that. All right, now the thing is, NFS is a little bit old, and internally it's a little bit complicated. That's why there are all of these utilities that start up, okay? etc exports, files, the configuration files, etc. All right? But most of this is automatic it's done automatically by the scripts, okay? And so there's only a minimal amount of command line work that needs to be done to get this set up on the server side and the client side. But one of the things that sometimes seems to get people a little confounded, all right, the server side is where things are actually stored, all right, and the client side is the remote one, right, that wants to add this to its directory tree. Okay, so on the server side, in our case here, right, the user server is the NFS server, and the web server is the NFS client, because files are actually going to be stored here. All right. And again, there's a way to make this permanent, all right? Or you can put it into a separate shell script, all right? I highly disrecommend making this permanent on the TinyNet machines, mostly because it slows things down terribly. If the NFS server is not running, it slows down the NFS client because it periodically checks to say, where's my NFS server? Where's my NFS server? And it can take a long time to time out, all right? So manually mounting the file system is the way we want to go, all right, with NFS for enhancement 3.2. So this is what the configuration files look like. A little bit of a caution, all right? You want to watch out for your spaces here. Again, we're not in a production environment, but this is one of the things that people find frustrating about NFS, right? Because its syntax is so picky, and it's just one of those things that we live with. All right, so we could set up some IP tables rules here. All right, we're not going to deal with that. And again, we're not going to get realistic about this, okay? Because we have a limited amount of time to devote to this, all right? Let's see, 1016 or 1018? 1017. All right. What have I got here? Okay, so here is, again, the first thing to do is just clone a new VM, user server, and, oh, there it is. All right, should be up there. But for part A, this is important here. All right. What you need to do is you take your to-clone server and clone it off. And then run the config cd, all right? And when you do the set role, look down the list, all right? And you'll see TinyNet no role, all right? No role, just enough configuration to get you connected to the network, and then no real specialized software being installed. It's all just the standard TinyNet configuration, but it's connected. By default, it will be connected on net B, but simple change will get it connected on net A. Then after that, it is setting some permissions, editing the monkey.conf configuration file, adding some CNAMEs. Oh, that part this part all should be very, very familiar at this point. All right. The only new part, is here, which is setting up the cron tab, the cron job. Okay, and we'll talk about that on Monday. All right. Then you can go on, once you get this part finished, move on. You have that one set up. All right. You edit the monkey.conf on your web server. Okay. Set up the mount point for NFS and export the top document root directory. Okay. And fix the CNAMEs so that they point to the web server and not to the user server. Okay. And that is kind of fully blown NFS installation, okay, for securely providing these virtual hosts to our various users. Now, something very important here, all right? Okay, something important here on Monday. Virtual hosts. Monday Lab, we're going to be talking about virtual hosts. And again, there is also in the TinyNet enhancements folder. All right. Part A through E is 3.1. All right. Leads you through it step by step. All right. 3.2 is the NFS part here. All right. And we'll be talking about this in the lab on Monday. Okay. Today lab, we're going to be doing something completely different. That's because all the people on the Thursday lab have ethical hacking next semester. Okay. All the people in the Monday lab, I think there's only a few people in forensics in the Monday lab that might, but we're going to talk about the virtual hosts on Monday. And this week for the Thursday lab, we're dividing this up a little bit because of the way the groups are divided. Down here at the bottom, special recommendations for people with ethical hacking. All right. This week, today, Thursday lab, we're going to be talking about Portnock and remote reverse shells. A long time ago, asked me about a bind shell. All right, that's just a different name for a reverse shell. Okay, and we'll talk a little bit about Netcat and things like that as well, because that's all hot stuff in the ethical hacking world, and in the black hat hacking world. All right. Next Thursday, we'll talk about the special configuration of the TinyNet as a victim network. If you're going to do ethical hacking, you need somebody to attack, all right? And you've got a special configuration that automatically generates traffic that can lead to some interesting exercises if you use your imagination. Okay? So Monday lab, Thursday lab, they're different. Right? Starting today, Thursday, they're different. And so you have to remember you only get attendance for the one you're scheduled in, but you've got lots of space in Teams meetings. And so if you want to come and get in on the explanation of the Portnox NetR, or the other way around, virtual hosts and the log files one, then take that into account, because we welcome visitors in the other lab. We're all one big group here. We're all one big group here. Yeah, I understand. We're all one big group here. And so, again, also applies, this question came up, also